Now we have to do another two processes belongs to number of processes. Polytropic process. Now we have to do the polytropic process. So on PV diagram, you can remember PV equals V line is like this. State 1 to state 2, right? Then polytropic process is P V to the power n is of equal constant. That is the law governing polytropic process. PV to the power n. Now PV equals C is somewhat rectangular hyperbola, but this is also the curve like this, Q to the power n 1 to 2. Then in this case, according to this relationship, P to the power n equal constant, you can have a P is a function of V. How it is? P is equal C to the power V n. This is the relationship Pn between P and V. So now, same like previous constant pressure, constant volume, isothermal processes, here also you can apply set of equations in determining the properties belongs to state 1 and state 2. Here P1, V1, P1, here P2, V2 and P2. Then you can apply P1, V1 equals MR P1, P2, V2 equals MR P2 and a state equation P1, V1 over P1 is equal P2, V2 over P2. This is where all these three very important, especially this third equation is very important for polytropic process. Getting use of these three equations, in addition Kp, Cv, R, those things also you can relate in determining R, and you can find out the properties belongs to state 1 and properties belongs to state 2. In other words, P1, V1, T1 and P2, V2, T2. The next is determining other quantities like dW, work done, heat transfer dQ and change in internal energy dE. So we'll see how do we do this. First, dW, work done. As you know, the work done is area under PV diagram. That means integral V1 to V2 P dV. You know, the previous the relationship between P and V, what is it? P is equal constant upon V to the power n. Okay, then in integrating we can do integral V1 to V2 instead of P you can write V to the power n dV. Okay. Okay, now you can integrate easily. dW is equal, so you can take it out, integral 1 over Vn dV. Okay. So again it is equal C times V to the power minus n dV. Integral V1 to V2. Simple. So again dW is equal, if you integrate V to the power minus n, what do you have? C is outside, V minus n plus 1 over minus n plus 1. V1 to V2. This is integration, right? This one integrate, you will get this. Then again C, you can write like this. C V2 minus n plus 1 C times and V1 minus n plus 1 or same thing minus n plus 1. This one. So then, you know that what is C? What is this constant? P V to the power n equal constant. Then what you can say? You can write P1 PV to the power n equal constant. Then P1 V1 to the power n equal again constant. Similarly, P2 V2 to the power n also equal constant. All are constant. Constant you can write like this. P to the power n, P1 V1 to the power n, P2 V to the power n. All thing is equal to C. Then instead of C, you can write like this. How do I write? The space. Space between. You can write C time equals C times V2 minus n plus 1 minus C times V1 minus n plus 1 divided by minus n plus 1. Okay? Only thing is we remove the brackets. That's all. Then again this is something extra. So again this is equal dW. Again this is equal. Instead of C here in V2. Because of C in V2 you have to write. Then this portion we are taking. V2. Here V2, then we will take this portion as C. P2 V2 and V2 minus n plus 1 minus, here C V1 is there, therefore this component you can take. Because we want to simplify. Then here P1 V1 and V1 minus n plus 1. I think you understood this thing. Right? Again minus n plus 1. Now this is indices. Indices. O level also you have done this. Right? Then here n minus n plus 1. This is P2 V2 n plus minus n plus 1 minus P1 V1 n plus minus n plus 1. Okay? Here and here. Right? Okay? Divided by minus n plus 1 means again 1 minus n also okay, no? 1 you can write like this also, no problem. Here n minus n plus 1. This everything cancel out. Okay, only 1 is remaining. Then that is equal, here you can write P2 V2 minus P1 V1 1 minus x. Okay, very simple. Now finally dW is equal P2 V2 minus P1 V1 divided by 1 minus n. This is your work done. Okay. Now you can find out work done like TW. Then the next is, now okay, you have done this. I'm going to clean this. After doing integration, all this whole thing, dW is this one. Then dW is found. Then applying non-flow energy equation, dW is equal T, dQ is equal du plus dW. dQ is equal du plus dW. dW is equal dQ minus dV. This dW form, this one, dW form. Then once you are given dQ or du, you will be able to find out W. If you are given du, then dQ can be found if you know dW. Then if you are given du, then dQ is this way. You can do this. I think that's all for the polytropic process. Adiabatic. What is adiabatic process? The next one will be adiabatic process. What is adiabatic process? Here in the polytropic process, you have P to the power n equal to. Adiabatic process, you have P to the power gamma equal constant. Instead of n, you have gamma here. What is this gamma? As you know, gamma is equal Cp over Cv as we have studied. That means P to the power gamma is a special process of polytropic, where the index, right? The index gamma is the index of compression or expansion. Here n also polytropic index. N is known as in the previous case, where n is polytropic index, right? Here gamma is ratio of specificity, gamma, instead of that index. Here the index is gamma. Adiabatic process is same like polytropic. I think you can do your own.